Okay, so for this question, what we're going to do is we're going to look at advanced factoring now. So in our advanced factoring methods, what's going to happen is you're going to have ax squared plus bx plus c, but our a value is going to be bigger than 1. And when your a value is bigger than 1, then we've got some stuff to work on that makes it advanced instead of just a regular magic x. So what we're going to do is take a look at an example of that so that we can see what to do with it. Our first problem is 6x squared plus 16x equals 6. And we're going to solve this quadratic equation. But if you notice, it's in the correct form, ax squared plus bx. We don't have a plus c. Like our c is here, but it needs to be over here. We need this equal to 0. So what we have to do first is subtract our 6 over so that we can get 0 all by itself over here. All right, so that's our first thing. Get it equal to 0. Now I have an ax squared plus bx plus c where the a value is bigger than 1. So this tells us right away that we are going to do advanced factoring methods. So to do advanced factoring methods, let me change my color quick. We are going to find our A and our B and our C, and we're going to make magic X. A times C on top, B on the bottom. So we have 6 times negative 6. That's going to give me negative 36. And we need a positive 16 for the bottom. So recall that when we are doing negatives on the top, that means that you have, what do we call it? Different signs. You need to find the difference. So you're going to subtract the factors. And what we need is a positive b. So that means that we need a positive big factor and minus a small factor. And the reason why we need minus a small is because big minus small is going to still give us a positive when we're done. So that is supposed to be an S. There we go. So now what we're going to do is write our factors of 36. So we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And we're looking for ones that subtract that give us 16. And that's 2 and 18. We know the big one is going to be positive, so we need a plus 18. And we know we need the small one to be negative, so it's going to be minus 2. However, here's where it becomes advanced. And what we have to remember is that since A is 6 up here, because A is 6, we need to start each factor with a 6x. All right, in the front. So over here on the side, 6x was something and 6x was something. Now we already know the big factor is 18, so we need a plus 18. And we know that the small factor is minus, so we need a minus 2. After you do that, you are going to rewrite, and we'll rewrite it right here. 6x plus 18 and 6x minus 2. And then we have to GCF each parenthesis and see if we can divide by something. So the biggest number that divides into 6 and 18 is 6. So we're going to divide that by 6, and that gives us x plus 3. The biggest number that divides into 6 and 2 is 2. And that gives us 3x minus 1. And this is our factor pair. So this is not our final answer, but this is what we need to set equal to 0. All right, remember, we're factoring this. We got it all factored. We set it equal to 0, and now each of these needs an equation. X plus 3 equals 0, 3x minus 1 equals 0, and we solve. So to get x by itself over here, we subtract 3 on both sides. To get x by itself over here, you need to do the right stuff first. The first thing you need to do is get rid of that 1. And you get rid of the 1 by adding it. So you're going to add or subtract first to get rid of anything, to get the x value alone. And then divide, because this is a multiply. So you're going to divide by 3 on both sides. And you get 1/3. You don't need a calculator for it. Here are your 2 answers. So the solution to this quadratic is -3 and +1/3. Those are your solutions. I'll get the second one ready and I'll see you in a minute. All right, here's our second one that you can write down. So if you notice, it's got an ax squared, it's got a bx, but it's not equal to 0. So the first thing that we have to do is subtract 6 on both sides to get it equal to 0. But 6 isn't a like term, which means we're just rewriting this. So this is going to be 35x squared minus 11x minus 6 equals 0. So you got to bring this over and set it equal to 0 so that we can actually work with it. Remember, when you bring it over, you got to use the opposite operation. So this was a +6. You're subtracting that over. Once you're here, you realize that this is going to be advanced factoring because your a value is bigger than 1. So our a value is 35. Our b value is -11. And our c value is -6. So to save some space, I think I'm going to put my magic X over here this time. A times c on top, b on the bottom. Calculators are good here. I need 35 times -6. And that is a -210. And then I need a -11 at the bottom. So I'm looking at this like, what? And what I need to do is I need to write that this is going to need to subtract the factors. This one's a -b. And so when it's a -b, we have to remember that we need a positive small one. I don't like it that way. I like negative big one and a positive small one. And the reason why we need to do that is because when your bigger one is negative, that's what generates a negative answer. I didn't want to confuse you. So the negative would have to go with the big one in order to get a negative answer. Let's take a look at our factors. I have no idea how many there's going to be. 210 divided by 1 is 210. 210 divided by 2 is 105. 210 divided by 3 is 70. So I knew that. 210 divided by 4 doesn't work. 210 divided by 5 is 42. 210 divided by 6 is 35. Keep going. 210 divided by 7. 210 divided by 8 doesn't work. 210 divided by 9 doesn't work. 210 divided by 10 is 21. Let's see if any of these work. I need to subtract to get 11. Starting here, 21 minus 10 is 11. Boom, I found it. So this is my factors, and this is what I need. I need a -21, and I need a +10, because this is how I'm going to get a -11. But, like I said before, since a is bigger than 1, since a is 25, I'm sorry, 35, you have to start your factors with 35x. So over here on the side, I'm going to have a 35x and a 35x. Now, I know my big one needs a minus, so I need a minus 21. I need my 10 is my small one. That's going to be a positive. And I'm going to rewrite. And look for GCF. So GCF of this, what's the biggest number that goes into both of these, is 7. So that's going to give me a 5x minus 3. The biggest number that goes into these two is 5. That's going to give me a 7x plus 2. And that is equal to 0. Now we're not done. We have to solve these. Okay, so this is why it's advanced factoring. You got to get it equal to 0. You got to do the thing with your magic x. You need to make sure that you put your first values in for a. Then you need to divide out a GCF on each of them. They have them. And then we get to split and solve. So we're going to split this into two equations. So I have 5x minus 3 equals 0. And I have 7x plus 2 equals 0. Hope I have enough space. Remember, to get x by itself, we got to add or subtract first. So we have to add the 3 over to get the x value alone. So that gives me 5x equals 0 plus 3 is 3. And then I have to divide by 5 to get x by itself. And x is equal to 3/5. There's my first answer. Let's look at this one. I got to add or subtract first. So in this case, I have to subtract 2 over. Other side of equals. That's going to give me 7x equals 0 minus 2 is negative 2. And then I'm going to divide both sides by 7. And when I divide both sides by 7, I'm going to get x equals, and this is negative 2/7. I've hit the bottom of the paper. So my final answers for this quadratic, the solutions to this quadratic, are 3/5. I'll put it over here. And negative 2/7. And we don't need to change it to decimals. We can leave it right in fraction form. And we're done. So this set of examples actually goes with the last 2 questions on your assignment. So when you're doing 47 and 48, I lied, 45 and 46, those are the ones that you're going to need to use the notes for this for. Okay, so this is the advanced factoring, but don't forget how to solve these. You got to make sure that you solve them and write them in curly brackets. Make sure you keep it in fraction form. Contact me if you have any questions. Good luck, everybody.